Greetings, family. I just wanted to go ahead and do what I'm going to start doing is what I call a lesson test preview. So, and basically during class we'll be having a lesson test, like an exit ticket that students can follow along with. So, and I'll be sending additional videos as well, so to cover specifically what we're going to be doing, as like I usually do. But this week we're going to be talking about 4.nf.3, which is all about either adding or subtracting mixed numbers or fractions. And we're going to talk about 4th grade style mainly, but there are some videos that I will send that will also help them with 5th grade, because it's really not that different. But it does piggyback off the two previous standards that we talked about last week, which is 4.nf.1 equivalent fractions and 4.nf.2. Now, for 4th grade math, with this standard of adding and subtracting fractions, these two other standards don't really matter. But the reason why equivalent fractions helps, it will help them with 5th grade, because they will not be able to add or subtract fractions without making equivalent fractions. So I'm just going to go ahead and dive right in. Now, one thing you do need to know about this standard here, the way it will show up on tests, sometimes they'll show you absolutely with just pure computation, and by computation it might mean 5/9 plus 2/9. And all you got to do, they'll just say solve this, and all you got to do is write 7/9, because 5 plus 2 is 7, and the denominator will stay the same. Well, if you think about the sneaky way, the standard, it will add it in a word problem. So that's where a lot of students I've seen get thrown off, because again, word problems just seem to scare a lot of 4th graders. Not all 4th graders, but some. So that's just what I do want y'all to be aware. So the first thing, let's just do the easy stuff first. The first thing is adding like fractions. And you need to know what a like fraction is. A like fraction is a lot like when they get older, they'll be talking about like terms. And so it means they have something that is the same, whatever it is that's in common. And with fractions, in this case, if they are like fractions, that means they have the same denominator. Like up here, they have the same denominator, both denominators of 9. Now, if it is unlike, it's just the opposite. So unlike fractions, in which 4th graders will see this when they are making an equivalent fraction, or if they're comparing fractions. So that means they do not, that means they're going to have different, and when they get older, unlike terms is when it's different. And in this case with fractions, different denominators. I could say 5/7, and 4th grade it'd be compared to 4/8. And so you can tell one has a denominator of 7, the other will have a denominator, say, of 8. Those are completely different fractions, whereas the fractions are the same. And so then that's where in 5th grade, if they had to, instead of comparing 4th grade, they just compare. But in 5th grade, if they had to add these, now it's a problem, because you have two different denominators and you can't add anything that's unlike. So you would have to turn them into having an improper, not improper, the same denominator. And so, yeah. So that's just the intro that I want you guys to understand. I just want to go ahead and dive right into the basics. We're going to do the easy stuff first, harder stuff last. And like I said, I'll have other additional videos that they're on YouTube. You can also type in exactly 4.nf.3, and it's going to show you exactly what's going to be on that standard. So the first thing is, know this: the denominators. Alright, so the denominators will stay the same. So basically the first thing you need to know is that the answer to whatever the problem is, it will be like fraction. So basically, if it's a like fraction, that means the denominator will be the same as the question, the problem. And you're also going to know that your main focus is on your numerator. So let's practice 3, 6 plus 2, 6. Now again, our answer is going to end up being a like fraction to the problem. So that means the denominator will stay the same. We see the denominators are 6. That means our answer is also going to have a denominator of 6 because it's going to stay the same, because it's all part of the same parts. Now we just focus on our numerators, and 3 plus 2 is 5. So the answer is 5 6. And I'll do another one. If we did 4, let's just say 17ths, plus 3 17ths, well, the denominator stays the same, and 4 plus 3 is 7, so the answer is 7 and 17ths. Now, sometimes you will have to simplify a fraction. That is also where the equivalent fractions will help with 4th grade math. If I said, let's do, okay, I got it, 2 tenths plus 3 tenths. That's going to equal 5 tenths. Now, I can actually make this fraction right here smaller. And I would need an equivalent fraction to simplify it, because the answer is wrong until you make it the smallest it could possibly be. I know I can divide both 10 and 5 both by 5, because that's their greatest common factor, right? If we were to do a T-chart, the only way I can do 5, it is a prime number, so only 1 times 5 could work. And I can do 1 times 10 and also 2 times 5. They both can be divided by 5 because they both have 5 in common as a factor. So I will divide by a whole fraction, 5 over 5, and make an equivalent fraction. 5 divided by 5 is 1, and 10 divided by 5 is 2. So the answer to that is 5 tenths, but you would have to simplify it. Alright, so now let's talk about subtracting fractions, because we're either going to add or subtract when it comes to this. I can do 4 tenths minus 1 tenth and get 3 tenths. Again, the denominator has to be a like fraction, so the denominators will stay the same. And we just focus on the numerators. Now I'll do one more for the sake of time. Again, the denominator stays the same. 5 minus 2 is 3. So this standard is pretty simple as far as simple adding or subtracting fractions. Now let's talk about adding and subtracting mixed numbers. With mixed numbers, I could say, and I'll just do adding because with subtracting it might get a little tricky depending on what we're doing. Let's do 5 and 2 sevenths plus 1 and 3 sevenths. Well, the best thing for you to do, just like with regular adding, you can just stack the numbers. So I would stack the bigger number on top. And because that 5 is there, I'm going to make that bigger because 5 is also bigger than 1. And I got my 1 and 3 sevenths. Again, these are both like because they still have the same denominator. So these are still like fractions or like mixed numbers. And so then whole to whole, you can only add your wholes because they're also like. I can't add this 5 to that 3 7 because those are two different things. This is a whole number. 3 sevenths is a fraction. Saying I can't add 1 to 2 sevenths because 1 is a whole number, 2 7 is a fraction. You can only add your whole to your whole and your fraction to your fraction. And again, the denominator is going to stay the same. Okay. And so let's just do whole to whole. So 5 plus 1 is 6. And then you just do your numerators. 2 plus 3 is 5. So the answer is 6 and 5 sevenths. If I do another one, and I say 4 and 3 ninths plus 2 and 4 ninths. I stack it up, bigger number on top. And this has to be the bigger number because that whole number is what gives it away. Whole to whole, fraction to fraction. My denominator stays the same. 4 plus 2 is 6. 2 plus, no, not 2. Sorry, 3 plus 4 is 7. So my answer is 6 7/9. Which is still pretty simple, right? This is basic math facts. Now, if I'm subtracting a mixed number, let's talk about that. I can do 6, and I'm going to go ahead and do the easy kind first because this is the easy kind. 1 and 2 7s. Now, let's check it out. Oop, I put 9. Not doing 5th grade, but they will see questions like that in 5th grade. Again, these are both like fractions because they both have a denominator of 7. The whole numbers don't matter. Just know you can only do your whole to whole and your fraction to fraction. Now, so let's just go ahead and dive right in. I would stack it. Bigger number on top, smaller number on the bottom. My denominator is still going to stay the same, even though we're subtracting. And I just do 6 minus 1, which is 5, and 5 minus 2, because again, numerators now, 5 minus 2 is 3. So the answer is 5 3/7. Now you might see something weird, and where you see 6 5/7 minus, say, 2, also 5/7. Now we see something different. And the reason why it's going to throw a lot of students off when they see something like that. That's because both the fractions are exactly the same. And when your fractions are exactly the same, it's going to cancel each other out. I'll show you. So, 6, again, whole to whole, fraction to fraction. The denominator stays the same. I would say 6 minus 2 is 4. But here's the thing. 5 7s minus 5 7s. That's like saying 1 minus 1. They're the exact same. So therefore, it cancels each other out. And your answer is just 4. I'll do another one. I'll do 5 and 3/6 minus 2 and 3/6. Now, what do you think is going to happen? We know our strategy. Whole to whole. Fraction to fraction. Now, the thing about this fraction is exactly the what? Yes, exactly the same. Which means these fractions will cancel each other out. And we'll just do the wholes. 5 minus 2 is 3. Now, you also might see another situation in where you might get a whole number of 3. And let's say 9/10 minus 3 and 4/10. Now, in this case, we see 3 minus 3. Now, the whole numbers are the same, but the fractions are different. Again, whole to whole, fraction to fraction. The denominator is going to stay the same. In this case, we can keep our fraction because we will have some fraction left, but we won't have any whole number. 3 minus 3 is 0. So you really don't have to write that down. And I'll just do 9 minus 4, which is 5. So the answer is 5/10 because the wholes this time cancel each other out. I'll do another one. 4 and 3/7 minus 2 and... Ooh, let me try to see what... Okay, 4 and 1/7. Again, these wholes are exactly the same, and they're actually going to cancel each other out. So I just do a fraction, and 3 minus 1 is 2. So the answer would end up being 2 7s. So I've talked about that, which to me is fairly easy if you just pay attention. Now it's about, I'm going to show you what the tricky part is, aside from the word problems. Again, this is just an additional video that you can show your scholar if they're having some problems understanding adding and subtracting fractions, because the other videos will take care of it, and we'll also talk about this in class. So let's go ahead and dive right in. Let's talk about regrouping fractions. Now, regrouping is what scares a lot of students because there are more than one step. Anytime we're regrouping fractions, you must remember what a whole fraction is, because we're going to need a lot of those. Okay, a whole fraction means the same number on top and bottom. Alright, so whatever number, it has to have the same number. Right? Same. I could even say A over A, B over B, C over C. It will be the exact same. But in this case, you can't just use any whole fraction. You're only going to have to use the one that the fraction's using. So I'm going to show you what I'm talking about. I'm going to say 5 1/3 minus 2 2/3. Now, we would still stack it. That's our first step, stack it. The bigger number will go on top. The smaller number will also go on bottom. Now, 5 minus 2 can be subtracted. I'm going to need some more room. I'm going to push this up a bit because I need some more room. When I say 5 and 2 1/3, 2/3. Okay. Now, I can do 5 minus 2 because 5 is bigger. But I can't do 1 minus 2 because 1 is smaller than 2. So just like how we do in math, we take from the larger number. I always say it like that with the students. We're going to take from the bigger number, and the only bigger number we have is our whole. Now 2 is fine. His group. Now 1 is going to borrow a whole from 5. So we're going to take from the 5, make that a 4. Now when you're borrowing, you're not just borrowing a 10. Fractions have to borrow a whole because again, that 5 is really whatever this number is, whole fractions put together. So that means it's 3/3 plus 3/3 plus 3/3 plus 3/3. So all these 3/3, right? Because a whole fraction is equal to 1, so it's 5 of those. Now, and you don't know what I'm saying, it's 3/3 plus 3/3 plus 3/3 plus 3/3. 1, 2, 3, 4, 5. So 5 of those whole fractions, and they just put it together and just made it 5. So we're going to borrow a whole fraction. Now, it has to have the same denominator, so we can only use 3 over 3. Now, the next step you have is you're going to borrow and then add that whole because, again, you're borrowing it. You're making it bigger. Just like if you were to borrow, you borrow 10 and add it to yourself. Well, you're going to borrow a whole and add that to himself. So 1/3 is going to add 3/3 to himself. And the denominator will still stay the same, but 1 plus 3 is going to be 4. So now we can actually subtract because 4 is bigger than 2. So in a way, and I'm just going to erase this, I'm going to link this to showing you this is a lot like borrowing with regrouping, right? Because you take from the 5, you take from the larger number, that 5 will become a 4, and then whenever you borrow and subtraction, regular whole number subtraction, you're always borrowing a 10. And so that 1 is like he's borrowing a 10, right? And so that 1 basically adds that 10 to himself and it ends up making himself 11. And then 11 minus 9 would be 2, and then 4 minus 4. So just like that, this here is the same thing. It's just fraction form. Instead, you borrow whole. So 4/3 minus, so now you can go ahead and subtract. Whole to whole, fraction to fraction. 4 minus 2 is 2. And 4 minus 2 is 2, and my denominator stays the same. Now, that was a whole lot of explaining, and I'm going to spend more time talking about that because that is going to be shown in your state test, probably just like this. This right here, they will see that. That's a promise. And it will show up in a lot of Master Connect. I don't know why they love regrouping fractions. I guess because it's more complicated and they want to see students know. So I'm going to set up some problems here. Now, let's look here. The wholes, the first step is always to stack it up. That's where you do anytime you're adding or subtracting, stack it up. And it's always best to put the bigger number on top and the smaller number on the bottom. Now, you probably could turn this into an improper fraction and still subtract it out, then turn it back. But I'm just going to show you a quick, simple way that we do. Again, always stack bigger number on top, smaller number on the bottom. And we know 3/5 is the small, 3 5/7 is the smaller number because 3 is smaller than 6. Now, if I look here, and again, you have to pay attention because you might accidentally skip this and not know by rushing that you would say, oh, 6 minus 3 and then 5 minus 2. No, you can't just do 5 minus 2 and get 3. Again, this bigger number is on top, so we have to obey the rule. And so, again, we're going to have to borrow because we can do 6 minus 3, but not 2 minus 5. That's where the red flag is. So anytime you see that red, that fraction where the bigger number's fraction is smaller, that right there is your red flag. And anytime you see a red flag, think about regrouping. And you're going to have to borrow a whole fraction. Okay? Or better yet, I would say our new symbol for whole fraction is SS, which means same. And in this case, we're going to have to use a 7, right? So let's go ahead and I'm going to borrow and make that 6 of 5. And I took a whole. And the only whole fraction with my denominator 7, that means the top will have to be 7. And then I would add it because it always, anytime you borrow, you're adding it to yourself. So 2 plus 7 is 9. 7. So the answer should always end up being an improper fraction anytime you borrow. And so now we can go ahead and subtract. 5 minus 3 is 2. And then 9 minus 5 is 4. And again, our denominator will stay the same because these are also like fractions. Alright, and so I want you to watch me do this one as well. And also for practice, you can do 5 and 2 9s minus 3 and 4 9s. You can do that for practice. Okay. Let me go ahead and do this. Stack it. Or you can even pause the video and like work it out and then press play. And also see if you got it right, so that can help. But you always stack it with the bigger number on top, smaller on the bottom. Again, red flag. 1 can't subtract from 2. So I have to borrow. And I make that 5 of 4. I have to borrow with a whole fraction. My denominator stays the same. So I'm going to add 3 over 3 because it has to be a whole fraction. And 1 plus 3 is 4. And my denominator stays the same. Now I can subtract. 4 minus 4 is 0. So you could put 0 there, or you really don't have to because it doesn't matter. It won't change your answer. But 4 minus 2 is 2, and my denominator will still stay the same, and it's 3. So the answer is really just 2/3. Alright, last thing, we've talked about, the pure computation where you're just looking at the fractions and solving it. Let me show you how the word problem gets students. This is what gets a lot of students. Okay? Alright, so here's an example how Mastery Connect, or even a benchmark, maybe even on the state test, they'll give a word problem with fractions. So let's just dive right in. Aang has 6 knives of bison food. Zuko brought 2 knives of bison food. What fraction of bison food is available now? Now, I see that they're not asking for how much more or less, so we have to be adding then. And so what we're doing, we're just adding 6 9s plus 2 9s. And again, this is easy. Our denominator will stay the same. And our numerator, 6 plus 2 is 8. Now, the test will try to trick students. They'll try to make them think that they're adding everything. And again, you're not adding the denominator like that. What you're doing here is Aang had 1, 2, 3, 4, 5, 6. Right? Zuko, he still has 9 parts as well, but instead he just brought 2. But if so, you were to fill those 2 in, that would end up being, so, or let's say, let me fix this. So you can visualize. I want you to visualize and see why the denominator has to stay the same. We're not adding 18 parts. We're not doing that. The parts stay the same. He didn't add a whole set. He just added 2. So again, these are Aang's and Zuko together. They have 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, the denominator stays the same, so that's wrong. And then we're not subtracting. We know they want to know how much they got together. That means what's the whole thing they have. The only answer you have is that. I'll give you another one. Now, again, how much more? Again, with this kind of standard, you have to absolutely pay attention to keywords and figure out what the question is asking you. So they want to know how. So Zuko ran 6/12 of a mile. Aang ran 5/12 of a mile. How much more did Zuko run than Aang? How much more is a keyword for subtraction? So you're subtracting 6/12. 6/12 minus 5/12. And the denominator still, these are like fractions, right? Which means our denominator will have to stay as 12. And 6 minus 5 is 1. So the only answer you could have is D, which is 1/12. The test might try to trick you and make you think that you're adding. It might think that you add everything, or it might act like you subtract, and 12 might, somebody might say, well, 12 minus 12 is 0, so that means I just put 1. No. So again, and let me add 5th grade style and show you why. And again, you don't have to see this part, but if you want to, this is just an additional tutoring help video with adding, subtracting fractions. So let me show you a trick. This trick won't work every time, but it can help. Now with regrouping, you're going to have to do the other way, and I'm going to show you in just a second, so just wait. Now you might have to do 1/3 and 1/2. Now again, we got some red flags here because these are unlike fractions and the denominators are not the same. In fact, rarely in 5th grade will the denominators already be the same. They want you to go the extra step in 5th grade and make them have the same denominator, and you would have to do an equivalent fraction. Now, the other way, the longer way, which they would have to do if it was something like regrouping a mixed number, but they can make them have the same thing if you were to use your multiples. So again, your multiples would be 3, 6, 9, right? 15. For this one, it would be 2. It could already make 2, but 2 times 2 is 4, 6, 8, 10, 12. So what we're going to use is the least common multiple. And that means they can both, the quickest thing they can both make is 6. Which means you would have to make them both have a denominator of 6. So, and again, we need 2 because we're adding 2 fractions. And then you would have to see what can you multiply by to make 3 equal 6. What whole fraction can we multiply by? And so I already know 3 times 2, right, would give you 6. And 1 times 2 would be 2. And I would say 2 times 3 would give me 6. And again, we have to multiply by a whole fraction because we're making an equivalent fraction. Alright, so 1 times 3 is 3. And then you would add 5 plus 3, which equals 6. Now, here's a little trick that a lot of people don't know about. And like I said, this way is quick, especially when it comes to this. This will work. Watch this. Multiply the bottom, cross multiply the tops. Alright, so what that means is you multiply the denominators. And so again, I would have 2 denominators. And again, 3 times 2 is 6 because we multiply the bottom. So you're going to multiply 3 times 2. Next, you cross multiply the tops. Now, whatever's on this side, it stays on this side and goes to this fraction that's on this side. If that fraction's on that side and that wing, you keep it on that wing. So cross multiply the bottom, cross multiply the tops. 1 times 3 is 3. 1 times 2 is 2. And we just drag it down. See how we had to make it have the same denominator? We have to turn these unlike fractions into like fractions. I'll do another one. 1/7 plus 2/3. Again, multiply the bottom, cross multiply the tops. 7 times 3 is 21. And we have 2 fractions, so we need 2 denominators of 21. Cross multiply the tops. 7 times 2 is 14. 1 times 3 is 3. And you just drag it down. And the answer, the denominator stays the same. 3 plus 14 is 17. Again, I hope this helps. And this is the 5th grade part, so just an additional step. And I can show you how this can add. This can do help with subtracting as well, with certain fractions. Let's say, alright, 1/3 minus 1/5. Again, multiply the bottom, cross multiply the tops. And this is with subtraction, so don't forget. Again, we're going to get our sides ready. And it's better, probably easier for students to just line it up right on that side. And so they know 3 plus 5 is 15. 1 times 3 is 3. 1 times 5 is 5. And the answer will be 2/15. Alright, so again, I want you to have a blessed day. Hope this helps. Take care.